Okay, all right. You understand that nighttime is obviously far more comfortable for me, right?
Oh,
So yeah, the problem is as of now, early morning is good, but early morning I think is not going to work for you, right?
early
No.
morning is fine for me.
Early morning normally you have school or something, right?
Yeah. On school days, yeah, but now it's fine.
Now
Yeah.
now I understand, but oh, early morning now you're actually good with early morning.
Yeah, I'm fine.
Till what time are you all right with it?
I have another class at tomorrow, like around. I'm not sure when the class is. He told me, he'll tell me. He said me somewhere before 11 o'clock, so I'm not too sure about that.
All right, okay, all right. Now, where was I? Forget about the classes. Now, your photos. That's why I switched off the phone. Send me your notes.
Yes, sir.
And how were you finding the alkanes, solving questions from alkanes?
It was okay, not too bad.
And
It was
what type of questions were you struggling with?
struggling with mainly like those like 1 second.
Is this the elementary one or is this the advanced one?
I mean the two levels. I did both. Like
Okay, all right. And all right, so hmm, let's see. So, what kind of questions have you had issues with predominantly?
like like the products which are formed from the reactions. Like mainly the questions are based on that. Like yeah, stuff like that.
Effectively, anything which is meaningfully complicated question.
Ah, and
And how have you addressed that issue?
I asked a few of my friends, and I got it cleared out. Yeah,
Effectively, you have just directly gotten it clear
yeah, yes, sir. I
as
mean,
doubts. All right.
most of
So,
the questions weren't. Yeah.
hmm. All right. So, effectively, can you give me a couple of examples of the questions you ended up having problems with when you say reaction type? Now, be a little bit more specific, please.
1 second.
Hmm.
I mean, not much of a problem, but one example is how many dichloro products, including stereoisomers, will be formed when R2 chloropentane reacts with Cl2 under UV radiation.
Hmm. 2-chloropentane reacts with chlorine in the presence of H nu. And you're going to be having in this particular case here, what exactly did they say? This is R configuration. Huh?
Yes, sir.
They
R2
specifically
chloropentane.
mentioned this is in some particular configuration. How many what
Hmm.
products?
Dichloro products.
Okay. So can you explain how to solve this?
Well, this chlorine can attack any of the hydrogens. Like,
Can we start off with what you need to do first? Let's first number, shall we?
I, yes, yeah.
Hmm. Now tell me, continue please. Where can the chlorine go?
The chlorine can attack any. It can pretty much replace any of the hydrogens. It can go
Hmm.
either at 1, 2, 3, 4, 5. Yes, yeah.
Okay. So let's start off with each place here. What is asked here? Number of dichloro products, distinct dichloro what?
Dichloro.
And
Yes,
have they
sir.
mentioned anything extra? Optically active dichloro, anything of that sort?
Including stereoisomers.
That is total.
Yes, total. Yeah, yeah.
Okay. All right. So let's start off then. So in this particular case, if it is attacking carbon number 1, right?
Yes.
Explain to me what are the products formed?
So
How many products are formed?
only one is found.
Why is there only one formed?
Oh, sorry. Give me a second. No, not 1 second. Two are formed. So because once chlorine comes in, then it will be CH2Cl, and then that carbon two is chiral. Then
I think I'll get my video on for a while. I would like to express my disappointment with my face. So, tell me again, please. Yes. Please continue your wonderful logic over there. I'm very much interested in listening to it seriously. Please. So, carbon 1, if the attack is happening, carbon 2 is suddenly going to become extra optically active. Is it correct? This carbon, which was already optically active in the first place,
it won't become.
is
Yeah.
a fixed configuration already.
Yes. Yeah.
What is going to happen to that?
Nothing will happen. It's already fixed.
Yes. So, this guy is going to give me only one
Only
product.
one. Yes.
How about here? If it attacks the second carbon,
There also one.
why one product there?
Because it can only attack that. There's only one hydrogen to attack there.
Okay, so I'm going to break this question down a little bit more. I'm going to ask all the optically active dichloro products as another possibility, and total is going to be another. I want you to mark it out as a point on x-axis and y-axis.
Quadrant axis.
And I'm going to basically make this even more trickier. I'm going to make another part over here. I'm going to ask for trichloro, or say I'm going to change the R to an S. And I'm going to have 2 points. I'm going to ask you the distance between those 2 points. Shit can be done. That's how your max questions are, correct?
Yes, sir.
So just because a couple of other subjects are a lot more creatively they're trying to make questions doesn't mean math doesn't. Math also does that once in a while. But same drudgery can be brought here also. And where if you can't even solve this step and you don't understand this, you're done. So let's proceed on. Is this second compound, if it attacks the second carbon, what is that compound looking like? Is it optically active, optically inactive? Give me more details, please.
It will be optically inactive.
Why?
It has a plane of symmetry. And I mean, first of all, there is no chiral carbon.
Yes, that's the goddamn answer I'm looking for.
I mean that also.
No, don't give me plane of symmetry shit. You're not supposed to look for plane of symmetry in the first place. What's the first thing you're supposed to look for when you're asked for optical symmetry?
Chiral carbon.
Yes. Your brain should not think plane of symmetry. If your brain is thinking plane of symmetry, you're already on the wrong track. That is the reason why you couldn't see in your brain that carbon 2 was already chiral. Because you stopped thinking chiral for a second. You started thinking plane of symmetry. To some extent, that was part of it, yes?
Yes.
All right, so third location. How many products?
Now if the chlorine attacks, it can. Give me a second.
How many products here?
1 second.
First of all, this is where you're going wrong first. Never goddamn think in the goddamn air. Sit and put pen to paper now. This is not other parts of chemistry. This is the part of chemistry which is most similar to mathematics. Put pen to paper. Keep writing, fill in more pages. Especially when you're not able to visualize it properly, put pen to paper. No thoughts over there. The problem here is you have to start understanding your intuition is your problem in most of these questions as of now. Why is your intuition your problem? Because you have not built it up yet. So to build up your intuition, you need to do mindless type of thing. That's why you that's why you liked solving straightforward questions in the same chapter. Because it felt a little bit more mindless and you got grinding done. Right, to an extent it felt, at least it should have felt a little bit like that.
It did, yeah.
Now, in this here, tell me here, carbon 3, if it is attacking, What will you be getting as a product here? You'll be getting this guy as a product,
Yes.
where I'll have this and this here, and this is fixed in R.
Fixed. So it's not really optically active.
Yes, but this carbon,
This up and down.
don't say that. Don't say that first. First
It's
of all,
not
don't call it as it's not
chiral.
really optically active. That is bad mistake
No,
there.
it's not chiral. What is it?
It is chiral.
I mean, the first. Okay.
It is chiral. It is
But
just
fixed.
fixed configuration where without anything else attacking at that location, it is not going to be changing. It is fixed. That's all. Nothing else. Nothing else.
So-
Don't add any extra information. That's what I was trying to say there. Don't add any extra information unnecessarily. So in this case here, this guy is also optically active now. Correct. So this can be either in R or S. That
RLS.
means I get
Up or down.
RR and RS.
Yes. Correct. Yeah.
What are the products obtained here?
Two are there.
What are they? What is the relationship between them?
Oh, 1 second. RRRS diastereomers.
Good. So we get a pair of diastereomers here. Fair enough?
Yes, sir.
Now, draw the same thing for fourth fellow there yourself and try and tell me what you get.
Yeah, and again, pair of diastereomers.
Good. In
Oh,
this
no,
case,
no.
what is critically interesting here?
It's symmetric.
Which one? One of them. We don't know which one though. Correct?
Yes.
Do not
1
assume it
second.
is the RR. Do not assume it is the RS.
Wait, we can find it, no?
You can find it, but I'm saying do not assume.
Okay.
And do not waste your time finding. It doesn't make a difference. One of them is optically inactive. So you're going to be
Yes.
having one optically active,
Meso.
other is meso.
Yes.
But both are applicable. So you end up getting two here, two here. And we got one here.
One in each of them. Yeah.
And how about in the 5 here?
This one, only one.
Only one. Good. So effectively, these are going to be your products over here.
Yes, sir.
Properly clear now?
Yes, sir.
Now, if we are to basically have this kind of a reaction happening, this is basically actually not that complicated a question. Now, let's go for some other question here. Any other more complicated questions which you had problems in this topic? Anything else which you struggled on normally, which you felt was tricky?
Nothing really. Nothing other than this.
Then you probably did not solve good enough questions then.
Yeah, I don't think I did.
Did you solve questions involving halogenation with respect to percentage yield of product, etc.?
Yes, I've done that. Yeah.
And did you solve questions related to halogenation, percentage yield with isomerism, with this type of thing added in? For instance,
With
in this
this-
question here, if I'm asking you, if I'm giving you in this question, let's say I'm adding you one more piece of information. What is the ratio for 1 degree is to 2 degree is to 3 degree chlorination attack?
1:3.8:5.
Beautiful. So in this here, I can make this question a little bit more complicated. I can ask you, what is the percentage yield approximate of each? You understand the idea here, right?
Yes,
How
sir, yeah.
the same thing can be extended. How would you
Yeah.
proceed in that particular case?
You can first find the relative amount of each of them.
So let me start off with one of them. Let me take two as a comparison and give me for ratio for the two of them. Which ones do you want to pick here?
Carbon 3 and carbon 4.
Fair enough. Okay, go for carbon 3 and carbon 4. They are both going to be same amounts.
Yeah. Yeah.
Why are they going to be same amounts here?
Because of the same number of hydrogens attached. Like it can attack either side. And
So now
they're
I'm
both
going to ask you a more
secondary.
complicated question here. What is the ratio of the products obtained between carbon 3 and carbon 4? If I'm going to be having products over here, say, let's call it as product from carbon 3 attack and product from carbon 4 attack. Is this ratio greater than 1 or equal to 1 or less than 1? What do you think it should be? You understand the
should
point of the question over here, right?
Yes, sir. Yeah.
I'm taking the product from the location 3, both products, and products from location 4, both products.
Yeah.
I'm going to look at the total amounts of both obtained. I'm going to take a ratio. Which is going to be greater and why? If they are greater. If it is not greater, if they are both exactly equal, why? Now, let's go to this ratio.
think
You have an answer for me?
I think so, but I don't know the reason exactly.
Please tell me. Huh? No, don't worry. Don't worry. Don't worry about the reasons right now. Let's see how your instinct is.
I think product 3 because the other
Product
two
3 is
inform
greater or lesser? What is the answer?
greater than 1.
Product 3 is going to be greater than
The product of
product 4. So that means product 3 by product 4 is going to be greater than 1. Is that correct?
Yes. Yeah.
Good. This has been a very wonderful example to show exactly how fucked up your instinct is. All right, so let me go back to the point over here. Let's take this. How did this ratio come?
Experimental.
How was this ratio theoretically understood? Now, this is where things get interesting.
Chlorine would.
Yes, tell me.
I'm not too sure, but think if chlorine is about to attack the third degree hydrogen.
Calm down. Calm down. Take a deep breath. Take a deep breath. Close your eyes. Take a deep breath and release it peacefully. Make sure your exhale is much longer than your inhale. Do this once or twice more. Now, do not get defensive. Stop being defensive. I want to put you in a corner. Why? I want to see how your instincts are with respect to the subject right now. Because my gut feeling is telling me your instincts are not well developed for the topic now. And I need to make sure your instinct understands that so that it doesn't ever rear its head. Because your instincts are not built at all right now. So, in this case here, this has nothing for you to get defensive about. I just want to show you what are the pieces which you need to start connecting from now on. And this is the first place where I'm going to be showing this to you in the first place. This is the first reaction, literally. So relax. You're not expected to know the pieces by yourself. And your teacher has not had time to patiently explain shit. He has not shown you the pieces which need to be connected. First of all, this reaction. Let's start off with
I think I have an answer.
Tell me now.
If the not sure if the plus charge is formed on a third degree carbon, it's more stabilized or something like that, maybe.
Again, what is your brain trying to do now?
Make up some reason.
No. It knows the answer now has to be the opposite. So it is trying to find excuses to basically fit the picture in. It knows the mold which it has to follow now. So it is forcing your information into the mold. And in doing so, it is making a blunder again. The blunder being, you're assuming it's a goddamn carbocation.
Yeah. That was my own problem. I'm not sure if that's.
You understand what I'm trying to explain to you here? Your instincts are dead wrong here. Your gut feeling as to what to do, that is correct.
Carbon free radical.
Yes, all of that is fine now because I have eliminated your options out, my friend. Stop praising yourself. This is not your brain doing this shit here. Stop praising yourself. Stop feeling good about it. What did you do just now? I gave you clear-cut information ruling out options. You can do this tomfoolery with someone who is not on par with you to see what is happening in your brain there. I can clearly see what your brain is doing here to me. Don't make excuses up. You are not able to see the connections at all. All you see are connections everywhere. You don't know what is the correct connection. You're not able to sense what is the correct connection in any way. All you see are connections everywhere. But the connections are there everywhere. Your job is to hone your instinct to move towards the correct connection. In this case here, how to recognize what connections to watch for. That is where the synopsis comes in handy. Your synopsis should not be fucking notes. For this reaction for halogenation, your synopsis should be 4 lines. Absolutely not more than 4 lines. And it should contain all of the information which you need to solve any sort of question. For instance, in this case here, what was the details you were lacking? Halogenation. The moment you hear the word halogenation, your brain should go, it's a free radical mechanism. Now, free radical mechanism. Now, what does that tell you? That tells you stability of free radical.
Has something to do with it.
Is the most important thing to pay attention to. Now, what type of species is a free radical? Is it electron rich or electron deficient?
Deficient.
Deficient. So this is electron deficient. So if this is an electron deficient species, what type of effect will it like? Something which donates electrons to it?
Donates, yes.
So what type of effect will it like?
Plus I, plus M, plus R.
Whatever you want to call it. Right, so these are the 2 effects it will prefer. What will be bad for it?
Minus.
Now, look at this compound here. Your brain told you this third is in the center. So best. Why? Because your blind assumption is this thing is going to be something where it is similar to carbocation, carbon free radical. Your brain automatically said middle, more crowded, best. Something of that sort?
No.
Oh no, you had no thought there. Okay, my mistake there. Sorry. I can see you did not go this step at all. Now I can see that. You never went this far at all. Your thought process never went this far. Okay, my mistake.
Yeah.
Sometimes kids also go down the path and then screw up also. Now the thing here is this chlorine here is a minus I group.
Yes.
So that is why the 3 is going to be not that good as 4.
Understood. Yes. Okay.
So understand the point here. So even though you expect them both to be 3.8, one will not be 3.8. One will be less than 3.8. The other will be slightly more than 3.8. Not necessarily more actually, because for this also the chlorine is minus I only. So both will be less than 3.8. But the 3 will be much less than 3.8 compared to the
delta minus.
Yes.
Plus.
So that is the thing which you have to start connecting here. So in this case here, to connect the pieces, what did you need as information? To understand the entire crux of this question, what did you need as information for halogenation?
Free radical.
Correct. All you needed to know in this entire thing is it follows free radical mechanism. And the moment you say free radical, the other thing should connect. That is free radical now. It is electron deficient. It should already be there in your brain connected with free radicals.
Yes. Okay.
If that has been populated with free radicals in your brain already, And once you know that electron deficient, that should automatically be populated with, oh, plus I plus R good for this, minus I minus R bad for this. If those connections are present and kept in your brain before you reach here, then you will be able to synchronize it relatively peacefully. That is the job. And once you have connected it, then you should recognize, okay, the reason why this stupid order is like this is because of the free radical part here. Now I have another question. If it is bromination, what is the order?
1 is to 82 is to 1600.
Somewhere around 1 is to 80 is to 1600, correct?
Yes.
Why is the order this way for bromine? Why is the other way for chlorine? Why is it like this? What is happening here? What does this tell you? What is the difference between the two of them? This is something which I'm 100% sure your teacher would have mentioned in your class at least once or twice, because this is quite commonly asked.
Yeah.
What was the excuse which sir gave you? You being a very smart, intellectual kid will be able to remember more or less close to verbatim what he would have told you. Tell me. That is your best suit, right? Go on. Let's see how your ego catches your checks.
So ego is something.
Something related to
size. I mean, obviously size, but then chart disparity.
Don't feel bad. I know I'm trying to put you on the spot, but that's for a reason. People like you and me work better when we are put on the goddamn spot. The two answers you gave me just now are actually more correct.
Charge disparity.
No, I'm not going to explain why it is more correct. That is up to you to think. Don't come up with random shit to connect them for the sake of connecting them now. So tell me, what is the reason why? What is happening here? What do you see here? If I'm looking for fluorine, what should be the order?
1 1 1.
Dude, really?
I think lesser. That's what they.
You give me lesser, but don't call it 1 1 1. What the fuck, really?
That's what you were given.
It is not 1 1 1. What nonsense?
Yeah.
It's not 1 1 1.
That's what I was. Yeah.
It is going to be closer to 1 1 1. It will be like 1.1, 1.15 or 1.2, some nonsense of this sort.
Something like that, yeah.
It will be still in this increasing order only. That is not going to be changing. Okay, there will be a difference, but the difference is going to be more subtle.
Yes, sir.
Now, what is it telling you? So if I'm asking you, what is really happening here? What is the best way to imagine? The best way to imagine is like this. I've told you in chemistry, what is the ideal thing there is? Visualization.
Yes.
So in this case here, the ideal way to visualize is like this. First off, who is the person who is going to be starting the reaction in the entire process here?
The halogen.
Good. So in this case here, that's why the sunlight or light or whatever shit is there. The light, or in the case of fluorine, nothing is required.
To break it into free radicals.
Good. It will break into free radicals in the first step, and that guy is going to go and perform an attack. So the attack is happening because the halogen atom is highly unstable and wants to go do the attack, correct?
Yes.
So now I am having a buffet available in front of me.
Oh, okay. I think I know it. Okay, yeah.
I have beggars in front of me now. Different types of beggars at different levels of starvation. So in the buffet here, it's a very interesting type of rule which is allowed here. I mean, it's not about a rule even. Buffet is basically food over here. So the point over here is when you're going to be having different types of food, the person who is going to be starving most doesn't give a shit if it is curd rice or if it is the most exquisite Afghani kebab or what to say, the most exquisite paneer malai, whatever nonsense. Yeah. So the idea here is when you are going to be having a very highly desperate species, highly unstable, highly disparate species that is not going to be giving a shit about selectivity.
Fluorine.
Now, as you go bigger in size, what happens is it is going to be something which is going to be having more and more stability.
Yes.
And as it is going to become bigger and bigger in size, it is going to have greater and greater stability. And that means that fellow is now less reactive. It is more choosy now. It is, yes, a beggar, but it is me or you being a beggar. And we are not going to be going and eating food from garbage even if we become a beggar, my friend. We will wait for the restaurant to close where we know that fellow will give us food. And we will make sure we have proper puppy dog faces. So the idea here is there is going to be differences in terms of preferences. Mainly because there is a difference in the stability of the species itself. In this case here, the chlorine is going to be far more stable as a chlorine atom compared to fluorine atom. Hence, the chlorine atom is a little bit more picky compared to the fluorine. But the bromine atom is far more stable compared to a chlorine atom. So it is enormously more picky compared to the chlorine atom.
Yeah. Makes sense.
That is the idea in this case here.